Hello, and welcome to Dr. S's Random Math Layer. In this video, and following subsequent videos, Dr. S hopes to bring the vast world of mathematics to a wide audience ranging anywhere from high school level to college level to graduate level and beyond. The videos will feature math problems and solutions in varying levels of difficulty and academics. Dr. S is living with Duchenne muscular dystrophy, and because of that his respiratory insufficiency makes it difficult for him to speak for long periods of time. That is why I, Microsoft David, am his assistant narrator for all videos in this YouTube channel. Today's video will cover basic conics from high school algebra and introductory pre-calculus, in the form of problem 1. If you liked what you saw, be sure to click subscribe at the end of this video. More videos are to come, so stay tuned folks. Here's the statement of problem 1. In the xy plane, graphically determine the number of points of intersection of the circle of radius 5, centered at the point -2, 1, with the cubic function y equals x cubed, minus 4. Then, find these points explicitly. Before we go on to solving problem 1, here are some quick facts and review. Recall that in the xy plane, the equation of a circle of radius r, centered at the point PQ, is given by x minus p whole squared plus y minus q whole squared equals r squared, which we label as 1. In general, in the xy plane, a cubic function y of x, is of the form ax cubed, plus bx squared, plus cx plus d, where a, b, c, and d are real numbers. This we label as 2. The critical points of 2 can be found by setting its derivative equal to 0. Using the quadratic formula, the x-coordinate of the critical points is given by x equals -b plus or minus the square root of b squared minus 3ac, all over 3a. In addition, 2 has a unique inflection point, that is, the point at which the concavity of its graph changes. This inflection point's x-coordinate is equal to the ratio of -b to 3a. For the cubic function in 2, let d equal b squared minus 3ac, in the formula for the x-coordinate of the critical points. If d is greater than 0, then there are 2 critical points, a local maximum and a local minimum. If d equals 0, then there is 1 critical point, the inflection point, and if d is less than 0, then there are no real critical points. We refer to d as the discriminant for the critical points of a cubic function. Get ready folks, because here comes the solution for problem 1. The equation of the circle given in this problem is x plus 2 whole squared plus y minus 1 whole squared equals 25. The equation of the cubic function was already given as y equals x cubed, minus 4. The equations and the graphs are color coordinated in view of figure 1. Note that this cubic function has only one critical point at 0, -4, which is also an inflection point. Moreover, the graph of this cubic function is in fact the graph of the function y equals x cubed, translated 4 units down along the y-axis. So based on figure 1, there are 2 points of intersection for the circle with the cubic function in this particular problem. We are not done yet, because we still need to find these 2 points of intersection explicitly. We shall do that next. Here we continue to solve problem 1. To find the 2 points of intersection in this given problem explicitly, we can start off by substituting y equals x cubed, minus 4, into the equation for the circle, which was x plus 2 whole squared plus y minus 1 whole squared equals 25. Then, after simplifying and rearranging terms, we obtain a degree 6 polynomial. X to the 6th power, minus 10x cubed, plus x squared, plus 4x plus 4 equals 0. Synthetic division allows us to factor this polynomial as x minus 1 times x minus 2 times x to the 4th power plus 3x cubed plus 7x squared plus 5x plus 2 equals 0. Note that the last factor cannot be factored further over the set of real numbers, and it has no real roots. In fact, one can check that it has 2 pairs of non-real complex conjugate roots. So we need to only consider the real roots 1 and 2, as the x-coordinates of the points of intersection. Therefore, the 2 points of intersection for the circle and the cubic function in problem 1, are given by the points 1, -3 and 2, 4. Dr. S hopes you enjoyed this video, and that you found it helpful in any way possible. If you have any questions, or are not sure about something, please get in touch with him at his email address in the About section of this YouTube channel. This was just the beginning, as the problems will get more challenging with time.